Okay, today we're going to learn how to create a graph from a systems of linear inequalities in a real life application or word problem. Okay, so let's look at number one. Suppose you can spend no more than $90 for compact discs and videos. Discs cost $18 each and videos cost $9 each. We're going to write a system of linear inequalities that shows the various numbers of discs and videos that you can buy. Okay, let's go in here and start underlining some of our key words or important pieces of information. I'm going to go back to the beginning and I'm going to see that I can spend no more than $90 for both compact discs and videos. Discs are $18 and videos cost $9. Okay, so since it's a systems of linear inequalities, just like we did with equations, we're going to identify our variables and create more than one inequality. Okay, so I'm going to assign x and I'm going to assign y. I'm going to go ahead and let x stand for the CDs or the compact discs, and y is going to represent videos. This way I can build my relationships. Well, since we're talking about a real life application and we're going to graph it, notice that my graph is all quadrant 1, where everything x and y are positive. I cannot have negative discs and I can't have negative videos. So therefore, my first constraint, all CDs have to be greater than or equal to 0. Because either I could buy all discs, no discs, or all videos, no videos. Therefore, y for videos can also be greater than, or has to be, or equal to 0. So far I have two, and we call them constraints, two inequalities, my conditions. The next relationship says, I can spend no more than $90 for both compact discs and videos. So we're talking about a money value here. Discs are $18 each and videos are $9. So $18 per CD and $9 per video. If I cannot spend more than $90, I either spend less than $90 or I can spend exactly equal to $90. So now I have these three inequalities I'm going to have to graph and choose the test points to shade. I'm going to go ahead and do these two first. If all x's are greater than or equal to 0, that's going to be this boundary line right here. All x's have to be positive. And it's a solid line because it's including 0. All y's have to be greater than or equal to 0, so here's that horizontal. Okay, now, if I notice the coefficients here in this constant, these are all divisible by 9. So I can simplify my inequality and put it in standard form. So 18 divided by 9 is 2. Oops. 9 divided by 9 is 1v, which is less than or equal to 90 divided by 9 is 10. Let me rewrite that for you. Since it's in standard form, let's make a quick graph. I'm going to look for x-intercept and y-intercept. X-intercept means I want x. So y-intercept is 0. And I think I have a v accidentally here for videos instead of y. There we go. So I'm going to plug in a 0 for y and solve for x. And I'm going to look at it as an equation because I want that point. So x would be 5, and my y-intercept is 5, 0 for that leg. Or my x-intercept. My y-intercept, if I want the y-intercept, I want y, which means x is 0. And I'm looking for y. And I'm going to treat this like an equation. So that means y is 10. So my intercept is 0, 10. Okay, so let's go ahead and graph those 2 points. 1, 2, 3, 4, 5, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, look at the inequality. It's also including, so that's going to be a solid line. And I'm not going to have the arrows because I cannot have negative CDs or videos. Now before I do my shading, I'm going to go ahead and label my axes. So X was the number of CDs, and Y is going to be the number of videos. And I'm going to have a title. So I'm going to put up here purchasing CDs and videos. Okay, so let's find out where our solution is, where we shade. Well, if all x's are greater than 0 and all y's are greater than 0, that's this entire quadrant. But we need to look at the relationship of this line. So let's go back to the standard form here, and I'm going to plug in a test point 0, 0. If 2 times 0 plus 0, I need to see if this is a true statement. Well, this is 0 plus 0. And 0 is less than, not equal, but it's less than 10. So I shade everything below this line because that's where the 0, 0 is located. Notice I'm not going to go beyond these two lines because those are also my conditions. So any ordered pair that's in this shaded region would be a solution set of how many discs or videos I could purchase and spend no more than $90. I'm going to choose one and test it. I'm going to choose this point right here. How about 2, 1? So I'm going to check 2, 1. That would mean 2 CDs, 1 video. CDs cost $18. So 2 times 18 and 1 times 9. Is that going to be less than or equal to $10? Oh, I'm sorry, $90. I have to go back to the original one. So this is $36 and this is $9. 36 and 9 is going to be 45. And that is less than or equal to 90. Okay, let's look at another problem, number 2. Here I have a salad contains ham and chicken. There are at most 6 pounds of ham and chicken in the salad. We're going to write and graph a system of inequalities to represent this situation. Okay, I'm going to go ahead and let X equal pounds of ham and Y is going to eat the pounds of chicken. Okay, and I'm going to go ahead and graph or title my graph, and we're going to be talking about salad. And in the salad we have pounds of ham and pounds of chicken. Okay, now we either have pounds of ham or we don't. So one of my conditions, X has to be greater than or equal to 0, and for chicken, Y has to be greater than or equal to 0. So there's my two conditions, and that gives me my boundary lines here. So that means everything is positive in quadrant 1. Okay, there are at the most 6 pounds of ham and chicken. So if I take the ham and the chicken, at the most I get 6 pounds. So that means I could have less than 6 pounds or exactly 6. Okay, so let's go ahead and graph this. I'm going to use intercepts again. So if I want x-intercept, I want x when y is 0. Well, if y is 0, x is 6. And for y-intercept, that means I want y when x is 0. So when x is 0, y is 6. So 1, 2, 3, 4, 5, 6, 0. 1, 2, 3, 4, 5, 6, 0. Equals solid line. I already know everything here is positive, but let's look at this line. Which side do we shade? So let's put in a test point, 0, 0. So 0 plus 0. Is that less than or equal to 6? Well, yes, 0 is less than, not equal, but less than 6. So since that is true, this side of the line has the 0, 0. So within the boundaries, this is my shaded region. That means any point inside this shaded region would be a solution to the systems of inequalities. That means it would be the x value to be greater than 0, the y value would be greater than 0, but together they would either have to equal or be less than 6. Okay, now we have a couple more on the other side of this worksheet that I'd like you to try in your groups or with a partner, and then we'll look at it together in class to make sure we know what we're doing, and then we'll proceed on individually with another practice.